In this video, I will discuss how to calculate the work done by a variable force in moving an object. Up until this point, we've only considered calculating the work done by constant forces. Let's take a look at an example of that. So here we have a block of mass m being acted upon by a constant force F, so that this force here is also F, and the object moves to the right at displacement delta r. Now to calculate the work done, which we learned in the beginning of the chapter, we would multiply the force by the displacement by cosine of the angle that is between the force vector and the displacement vector. So this expression in this particular case would reduce to force times displacement times the cosine of 0 degrees, because the force vector and the displacement vector are parallel to one another, so that's a 0-degree angle, and the cosine of 0 degrees is 1. So the work done would be equal to the force times the displacement. Now, if we were to consider plotting a force versus displacement graph, what do you think it would look like? Well, since the force is of constant magnitude throughout that whole displacement, hopefully you're thinking it will be a horizontal line. Let's give some examples or some numbers here to help you understand it. Let's say the force is, say, 5 newtons to the right, and the displacement is, say, 10 meters. Well, if you were to calculate the work done, we would take that force of 5 newtons, multiply by the displacement of 10 meters, and you would get 50 newton meters, or 50 joules of energy. Well, if you take a look at this graph over here, where you have force versus displacement plotted, what do you think that would represent on that graph? So the force is 5 newtons here, and the object is moving a displacement to 10 meters. So this is delta r here. Hopefully you're thinking it represents the area under this curve. So your big idea here is that your work, in general, is equal to the area under a force versus displacement graph. If the force is acting along the x-axis, we could call that the force sub x, and the displacement is along the x-axis, we could call that, say, delta x, and so we could call this an x and this as force along the x-axis. Well, what would happen if the force was not constant? Here is just a constant value, so you could use this formula. Could you use this formula in all cases? What happens if the force is varying? Let me give you an example of what that would look like. If you had something like this, and your graph is a relatively simple shape, then you could use geometry to find the area under the graph. And you would break this up into little triangles and rectangles, and simply start your problem by writing the work is equal to the area under the graph, and then go ahead calculating all this area. Now, just like you learned when we dealt with, say, velocity versus time graphs, and you took the area under those graphs, you got displacement. When the area was above the horizontal axis, that was positive. However, when the area was below the horizontal axis, this would be negative area. So do follow the same rules that we learned before. If you want a calculus definition, for those of you guys in calculus, work is really equal to the integral of the force dot dx multiplied by the dx, and this is from the initial position to the final position. Now this is not a calculus-based course, but this is the more appropriate definition of calculating the work done. So if you had something a little bit more complex, something like this, then you would have to to get the more precise answer, you'd have to use calculus. But in this course, since we don't have calculus, it's not a calculus-based course, then the only way to solve this problem is to break up the area into little rectangles and calculate the area of, say, one rectangle, and then find out approximately how many rectangles you have enclosed here, and then get a rough idea by doing the area under the curve. If you had calculus, then you would probably know what this f of x as a function is, and then you could integrate it. But this is not about a calculus-based course. Okay, so the main idea here is whenever you need to find the work done by a variable force, where the force is varying over that displacement, the work done is the area under the force displacement graph between the initial position and the final position.